Close your eyes and imagine standing in Yellowstone National Park on a cool evening. The sun has set behind the mountains. Stars begin to appear in the darkening sky above you. You breathe in the crisp mountain air. It carries the faint scent of sulfur and steam. Around you, the earth seems to whisper and sigh. You are standing on something remarkable. Something that most people never truly understand. Beneath your feet lies one of Earth's greatest sleeping giants. A supervolcano. But this giant is not the monster that movies make it seem. It is more like a patient, ancient heart. Beating slowly. Dreaming deeply. Resting in the embrace of geological time. Feel the solid ground beneath you. It seems so stable. So permanent. Yet this ground is actually floating. Like a raft on an ocean of molten rock. The magma chamber below stretches for miles in every direction. Wider than entire cities. Deeper than the tallest mountains. This underground ocean of liquid stone has been here for hundreds of thousands of years. It moves like thick honey. Flowing in currents you cannot see. Creating pathways through solid rock. Building pressure with the patience of centuries. The heat from this molten heart finds ways to reach the surface. Like breath escaping from sleeping lungs. It creates the hot springs you see bubbling around you. The geysers that shoot steam high into the air. The colorful pools that look like scattered jewels on the landscape. Each hot spring tells a story. Water falls as rain and snow on distant mountains. It seeps down through cracks in the rock. Deeper and deeper it travels. Until it meets the heat from below. The water becomes warm. Then hot. Then superheated. This heated water wants to rise. Like a balloon filled with warm air. It finds cracks and pathways back toward the surface. Along the way, it dissolves minerals from the rocks. These minerals paint the pools in brilliant colors. Orange and yellow and green and blue. When this heated water finally reaches the surface, it creates the thermal features you see. Some bubble gently like a pot of soup on a stove. Others erupt dramatically like Old Faithful. Each one is connected to the vast heat source below. The giant beneath your feet is not angry or dangerous in the way you might think. It is simply alive. Breathing through these surface features. Releasing small amounts of heat and pressure every day. Like a person sighs to release tension. Scientists call this place a caldera. The word sounds mysterious, but it simply means a large bowl-shaped area formed by volcanic activity. Long ago, the ground here collapsed inward, creating a gentle depression. Like the way your mattress dips when you lie down. This collapse happened after the last major eruption. About 640,000 years ago. An almost impossibly long time before humans walked on Earth. The eruption was so large it changed the shape of the land itself. But then, like a tired giant, the volcano settled into sleep. Since then, it has been resting. Dreaming. The magma chamber slowly refills, like a bathtub filling with warm water. Gases dissolve into the molten rock. Heat builds gradually. But this process takes geological time. Time measured in hundreds of thousands of years. You are witnessing something that exists on a completely different time scale than your daily life. While you think in minutes and hours and years, this giant thinks in millennia. While you rush through your day, it moves with the patience of stone. The ground beneath you rises and falls like a sleeper's chest. Scientists measure these tiny movements with sensitive instruments. Sometimes the ground lifts a few inches over several years. Sometimes it sinks back down. This breathing happens so slowly that you would never notice it in your lifetime. These gentle movements are not signs of danger. They are signs of life. The giant is simply adjusting its position. Like you might shift in your sleep to find a more comfortable spot. The magma below expands and contracts with temperature changes. Gas bubbles rise and fall. The giant settles deeper into its rest. Earthquakes occasionally shake the region. most are so small you would not feel them. They happen as rocks adjust to the slow changes happening deep below. Like the creaking of an old house settling on its foundation. These tiny movements are part of the giant's natural breathing. Standing here in the darkness, you begin to understand something profound. You are not separate from this sleeping giant. You are part of the same earth. The same story. The minerals in your bones came from ancient rocks. The water in your body once flowed through underground streams. The air in your lungs contains gases that bubbled up from thermal pools. You and this giant share the same planet. The same history. The same future. You are both made of recycled stardust. Both temporary arrangements of atoms that have existed since the beginning of time. Both part of Earth's ongoing story. The giant dreams of eruptions that may never come. Of pressure that builds and releases in cycles longer than entire civilizations. Of heat that flows like slow rivers through corridors of stone. These are dreams measured in geological ages. As you breathe in the night air, you realize that you are breathing in the breath of the giant. The steam rising from hot springs. The gases released from thermal pools. The oxygen created by plants that grow in this heated soil. All of it cycling through you. Connecting you to the deep processes of the earth. The sleeping giant is not something to fear. It is something to marvel at. A reminder that you live on a dynamic, living planet. A world where continents drift like clouds. Where mountains rise and fall like waves. Where solid rock flows like water, given enough time. Tomorrow, when you wake, the giant will still be dreaming. Still breathing through its thermal features. Still adjusting its position with movements too slow for you to perceive. Still teaching patient lessons about the deep rhythms of our planet. But tonight, as you prepare for your own sleep, you can rest knowing that you understand something new. Something profound. You have met one of Earth's greatest sleeping giants. And you have learned that even the most powerful forces on our planet know the value of rest. As you drift toward sleep, you might wonder what other giants dream beneath the surface of our world. What other patient hearts beat in the darkness below, waiting for their time to speak in the ancient language of heat and stone. Feel the warmth in your chest as you breathe. This gentle heat that keeps you alive is not so different from the heat that moves through the earth beneath you. Both follow ancient patterns. Both speak in languages older than words. Your blood carries warmth through the pathways of your body. It flows through vessels like rivers through a landscape. When you are cold, your body pulls this warmth toward your center. When you are warm, it spreads the heat to your skin. This is how life maintains its balance. Deep in the earth, molten rock moves in similar patterns. Hot magma rises from the depths like warm blood rising to your face when you blush. Cooler rock sinks downward like blood returning to your heart. These currents have been flowing for billions of years, creating a slow circulation that keeps our planet alive. The temperature deep below your feet is almost impossible to imagine. In the magma chamber beneath Yellowstone, the rock is heated to nearly 2,000 degrees. Hot enough to melt copper. Hot enough to turn sand into glass. Yet this incredible heat moves through stone as gently as warmth moves through your sleeping body. This heat does not come from fire as you know it. There are no flames dancing in the darkness below. Instead, the heat comes from the earth itself. From the slow decay of radioactive elements buried in the rock. From the leftover warmth of our planet's birth 4.5 billion years ago. Think of how your body stays warm long after you have eaten a meal. The food becomes energy. The energy becomes heat. This heat spreads through you gradually, keeping you comfortable even while you sleep. The Earth works in much the same way. Radioactive elements in the deep rock slowly break apart. Each time an atom splits, it releases a tiny amount of heat. Billions upon billions of these tiny heat sources warm the Earth from within. Like countless small candles burning in a vast cathedral of stone. This heat wants to rise. Just as warm air rises from your skin on a hot day. But rock is not air. Rock is thick and heavy, so the heat must find other ways to travel upward. It moves through cracks and crevices, through spaces between crystals, through pathways worn smooth by millions of years of patient flow. As this heat rises, it changes the rock around it. Cold rock is brittle and hard, but heated rock becomes soft and flexible, like clay in the hands of a potter. The heat teaches the rock to bend instead of break, to flow instead of shatter. In some places, the rock becomes so hot that it melts completely. This liquid rock is called magma. It moves like thick honey through underground chambers, finding the easiest paths upward, following the ancient highways carved by heat and time. The pressure deep underground is as important as the temperature. Imagine holding your breath and feeling the gentle pressure in your chest. Now imagine that pressure multiplying thousands of times. This is what rocks experience miles beneath the surface. This enormous pressure changes everything. Water that would boil instantly at the surface remains liquid in the depths. Gases that would expand and escape are squeezed into tiny spaces. The pressure holds everything together like a gentle but incredibly strong embrace. When magma begins to rise toward the surface, the pressure around it slowly decreases, like the feeling of relief when you finally exhale after holding your breath. As the pressure drops, dissolved gases in the magma begin to form bubbles, like opening a bottle of soda that has been shaken. These gas bubbles make the magma lighter. They help it rise faster through the rock above. The bubbles grow larger as the pressure continues to decrease. What started as a slow, thick flow becomes something more energetic, more eager to reach the surface. But most of the time, this rising magma never makes it all the way to the top. It gets trapped in underground chambers, like water pooling behind a dam. Here it sits and waits, slowly cooling, slowly releasing its gases through cracks and fissures that lead to the surface. This is why you see hot springs and geysers in Yellowstone. They are the Earth's way of releasing small amounts of heat and pressure gradually, like sighing to release tension. These gentle releases prevent larger, more dramatic events. The gases that escape carry messages from the deep Earth. They tell scientists about the temperature and chemistry of the magma below. Some gases smell like rotten eggs. Others are invisible and odorless. Each one is a word in the Earth's vocabulary. Water plays a special role in this underground conversation. Rainwater and snowmelt seep down through cracks in the rock. This water meets the rising heat from below. It becomes superheated steam. Steam that is much hotter than boiling water but still trapped underground by pressure. This superheated water can dissolve minerals from the rocks around it. It becomes a liquid sculptor, carving new pathways through solid stone, creating underground rivers and lakes of hot water, building the plumbing system that feeds Yellowstone's thermal features. When this hot water finally reaches the surface, it has traveled an incredible journey. From the sky as rain, down through miles of rock, into contact with the Earth's deep heat, and back up again carrying dissolved minerals and gases. Each drop tells the story of this amazing voyage. The colors you see in hot springs come from these dissolved minerals. Iron creates reds and oranges. Sulfur adds yellows and greens. Silica forms the white and gray deposits around the edges of pools. Each color is a word in the Earth's chemical language. Temperature gradients create different communities of life around these hot springs. Heat-loving bacteria thrive in the hottest water. They paint the pools with brilliant colors. As the water cools, different organisms take over, creating rings of life adapted to specific temperatures. This is the Earth speaking to you in the language of heat and stone. Every hot spring is a sentence. Every geyser is an exclamation. Every steaming vent is a whispered secret from the depths below. As you rest tonight, your own body speaks this same language. Your warmth flows through you like magma through rock. Your breath creates pressure and release like gases escaping from the Earth. You are part of the same conversation that has been happening since the world began. And tomorrow, you will learn how this patient conversation between heat and stone can sometimes write its messages across entire continents, building mountains and carving valleys in the slow script of geological time. Imagine lying on your back in a field at night, looking up at the stars. The ground beneath you feels solid and permanent. But if you could speed up time like a movie, you would see something magical. The continents above you are moving, drifting across the surface of the Earth like clouds across the sky. This movement is so slow that you cannot feel it in your lifetime. But it never stops. North America moves about 2 inches away from Europe each year, about as fast as your fingernails grow. The Atlantic Ocean becomes a little wider with each passing season. The Pacific grows smaller. Our planet is constantly reshaping itself. Deep beneath the oceans, the Earth creates new seafloor, like a slow conveyor belt made of rock. Hot magma rises from the depths and hardens into new stone. This fresh rock pushes the older seafloor away from the center, spreading outward in both directions, creating space for the continents to drift. Picture the Earth as a giant, slowly beating heart. The continents are carried along on plates of rock that float on the molten layers below. These plates move like pieces of a jigsaw puzzle that is always rearranging itself. Sometimes they pull apart. Sometimes they push together. Sometimes they slide past each other like dancers changing partners. In certain special places on our planet, something even more remarkable happens. Deep columns of hot rock rise from the very center of the Earth, like invisible elevator shafts reaching from the core to the surface. These are called hotspots. They are the Earth's way of releasing heat from its deepest places. Unlike the moving plates above, these hotspots stay in the same position for millions of years. They burn like steady candles in the darkness below. When a continent or ocean floor moves over one of these hotspots, something wonderful begins to happen. The hot rock finds a way to the surface, creating volcanoes, building islands, growing mountains from the bottom up. The Hawaiian Islands tell this story perfectly. Far out in the Pacific Ocean, a hotspot has been burning beneath the seafloor for millions of years. As the Pacific Plate slowly moves northwest, this hotspot creates a chain of volcanic islands, like a sewing machine stitching a line across blue fabric. The big island of Hawaii sits directly over the hotspot right now. This is why it has active volcanoes. Why lava flows into the ocean, creating new land every day. The island is still growing, still being built by the patient fire below. But the other Hawaiian islands have already moved away from the hotspot, carried northwest by the drifting plate. They are older now. Their volcanoes have gone quiet. Plants and coral reefs have covered their rocky slopes. They have become gardens floating in the sea. Yellowstone sits over a similar hotspot. But this one burns beneath a continent instead of an ocean floor. For the last 17 million years, this hotspot has been creating volcanoes as North America slowly moves southwest above it, like a torch held beneath a sheet of moving paper. The hotspot has left a trail of volcanic evidence across the western United States. Older volcanic areas in Nevada and Oregon mark where this hotspot used to be. Each one shows where the continent once sat above this steady flame. The track runs like a dotted line across the map, telling the story of movement too slow for human eyes to see. This is how mountains remember how to grow. Not all at once in dramatic eruptions, but slowly, patiently, over vast stretches of time. Each volcanic episode adds new rock to the landscape. Each lava flow becomes part of tomorrow's foundation. Each ash deposit enriches the soil for future forests. The Yellowstone hotspot has created some of the most spectacular volcanic features on Earth. Not just the current caldera that you can visit today, but a whole series of volcanic centers stretching back through time, each one marking a moment when the continent paused above this deep source of heat. Scientists can read this story in the rocks. They find layers of volcanic ash buried in sediments across the western states. Each layer is like a page in Earth's diary, recording the moment when Yellowstone's hotspot spoke in fire and steam. These ash layers help scientists understand how the continent has moved, how the hotspot has changed, how mountains have grown and evolved. The most recent chapter in this story began about 2 million years ago. 3 massive eruptions have shaped the Yellowstone region since then, each one larger than any volcanic event in recorded human history, each one changing the landscape in ways that still affect the region today. But between these rare, dramatic events, the mountain building happens more quietly. Magma intrudes into older rocks without reaching the surface, like bread dough rising slowly in a warm kitchen. This underground activity lifts and tilts the land above, creating gentle domes and ridges, building the foundation for future peaks. Hot springs and geysers are part of this mountain building process too. They carry dissolved minerals from deep in the earth. When this mineral-rich water reaches the surface and cools, it deposits layers of silica and other compounds. Over thousands of years, these deposits build terraces and cones, creating new landscape features one tiny layer at a time. The thermal features you see in Yellowstone today are like construction sites, places where the earth is actively building new rock formations. The colorful deposits around hot springs will become stone. The travertine terraces at Mammoth Hot Springs are mountains in the making, growing so slowly that you could watch them for a lifetime and barely notice the change. This is the Earth's way of remembering how to create, how to transform heat and pressure and time into landscapes that will outlast civilizations. The mountains you see today were once molten rock in the depths. The valleys were carved by waters heated in underground chambers. The forests grow in soil enriched by ancient volcanic ash. Everything around you is part of this slow dance of creation. The rocks beneath your feet, the minerals in the water you drink, the nutrients that feed the plants and animals. All of it came from the Earth's patient fire. All of it was built by the same forces that continue to work today. As you drift toward sleep tonight, you can rest knowing that you live on a planet that never stops creating, never stops growing, never stops dreaming of the mountains it will build tomorrow. The Earth carries you like a sleeping child, always moving, always changing, always building the landscape of the future from the fires of its deep heart. And beneath this gentle, continuous creation lies an even more remarkable story of how sometimes the Earth's patient building process must pause to take a deep breath, creating the vast spaces where tomorrow's mountains will grow. Place your hand on your chest and feel it rise and fall with each breath. This gentle movement happens thousands of times each day without you thinking about it. Your lungs fill with air, lifting your ribs outward. Then they empty, and everything settles back down. This rhythm of expansion and collapse is one of life's most basic patterns. The Earth breathes in much the same way. But instead of air filling lungs, molten rock fills underground chambers. Instead of seconds between breaths, the Earth takes thousands of years. And sometimes, after holding its breath for a very long time, the Earth must exhale in ways that reshape entire landscapes. Beneath Yellowstone, a vast chamber of magma has been slowly filling for hundreds of thousands of years. Picture a massive underground balloon, growing larger and larger as hot rock rises from the depths. This chamber stretches for miles in every direction. Deeper than the deepest lakes, wider than the largest cities. As this chamber fills, it pushes upward against the rock above. Like blowing air into a balloon, the pressure from below causes the ground to bulge slightly. Hills rise. Valleys shift. The land itself begins to arch upward like your chest when you take a deep breath. But rock, unlike rubber, has limits to how much it can stretch. And magma chambers, unlike balloons, sometimes empty very quickly. When this happens, the rock above has nothing left to support it. Gravity takes over. The ground begins to sink. This sinking does not happen like an earthquake, with violent shaking and sudden destruction. Instead, it occurs like the gentlest of sighs. The land settles downward slowly, gracefully, creating a large bowl-shaped depression. Scientists call this a caldera, from a Spanish word meaning cauldron. Imagine watching a souffle collapse in slow motion. The puffy top that once rose high above the pan settles inward, creating a gentle depression in the center. The caldera forms in much the same way. What was once the highest part of the landscape becomes a valley. What were once slopes become walls. The Yellowstone caldera formed this way about 640,000 years ago. Before that moment, the land looked very different. Mountains rose where valleys exist today. Rivers flowed in directions they have never flowed since. The entire shape of the landscape was transformed in this single, enormous exhale. But this was not a violent destruction. It was more like a gentle settling. A rearrangement that created something new and beautiful. The collapsed area became a natural basin. A place where water could collect. Where sediments could accumulate. Where new forms of life could take root and flourish. Think of how a dimple forms when you press your finger gently into soft clay. The clay does not break or shatter. It simply moves aside, creating a new shape. The caldera formed in a similar way. The weight of the overlying rock pressed down into the space where magma had been, creating a depression that would become home to forests, lakes, and meadows. The walls of this great bowl tell stories written in layers of rock. Each layer represents a different time in Earth's history. Volcanic ash from ancient eruptions. Sediments deposited by prehistoric lakes. Lava flows that filled valleys and carved new ones. All of these layers tilted and folded when the land settled, creating a readable record of geological time. Water played an important role in shaping the caldera after it formed. Rain and snowmelt collected in the depression, creating lakes that lasted for thousands of years. These lakes deposited fine sediments across the caldera floor. Layer by layer, season by season, they filled the deepest parts of the bowl with materials that would become fertile soil. Rivers found new paths through this changed landscape. They carved channels through the soft sediments. They cut gorges through harder rock. They created the network of streams and valleys that you can see in Yellowstone today. Each waterway tells part of the story of how the land has healed and adapted since the Great Collapse. Plants were among the first to discover the gifts that the caldera offered. The volcanic soils were rich in minerals. The protected basin created microclimates where different species could thrive. Seeds carried by wind and water found new homes in this transformed landscape. What had once been a site of dramatic change became a garden. Over hundreds of thousands of years, forests grew where mountains had fallen. Meadows spread across the caldera floor. Hot springs created warm refuges where plants and animals could survive even the harshest winters. The collapsed landscape became more alive, more diverse, more beautiful than it had ever been before. The thermal features that make Yellowstone famous are possible because of this collapse. The caldera walls created fractures in the rock. These fractures became pathways for heated water to reach the surface. Without the caldera's gentle architecture, the geysers and hot springs might never have formed. Today, if you stand at the rim of the Yellowstone caldera, you might not even realize you are looking at the edge of a collapsed volcanic chamber. The walls have been softened by time, covered by forests, carved by streams. The dramatic event that created this landscape has been healed by centuries of gentle growth. But the caldera is still there, still breathing in its slow, geological way. Scientists use sensitive instruments to measure tiny movements in the ground. Sometimes the caldera floor rises slightly as magma moves below. Sometimes it settles back down. These movements happen so slowly that you would never notice them in your lifetime. This breathing is not a sign of danger. It is a sign of life. The earth beneath you is still active, still changing, still following the ancient rhythms of expansion and collapse that have shaped our planet for billions of years. The caldera that formed in a great exhale continues to breathe quietly, almost imperceptibly, in the present moment. As you prepare for sleep, you can think of yourself as part of this same gentle pattern. Your own breathing connects you to the earth's breathing. Your chest rises and falls in rhythm with forces much larger and older than yourself. You rest in a landscape that was created by the planet's own need to rest, to release, to settle into a new and more comfortable position. The collapsed mountains of the past created the fertile valleys of the present. The ancient exhale created space for today's forests and meadows. And in this cycle of gentle collapse and patient regrowth, you can find a deep peace that comes from understanding your place in Earth's longest, slowest breath. But beneath this peaceful surface, something even more remarkable waits in the darkness, vast chambers where liquid rock moves like underground rivers, creating the hidden architecture that brings the Earth's deep warmth to the world above. Close your eyes and listen to the silence around you. But this silence is not empty. If you could hear deeply enough, you would discover that the earth beneath you is filled with the quietest music imaginable. A symphony so slow and gentle that each note lasts for centuries. Each movement spans thousands of years. Deep below Yellowstone, in chambers carved from solid rock, molten stone moves in patterns as graceful as any dance. This liquid rock, called magma, flows like thick honey on a cold morning. It moves so slowly that you could watch it for your entire lifetime and barely see it change position. Yet it never stops moving. Never stops creating its patient, underground symphony. Picture the largest concert hall you have ever seen. Now imagine it carved entirely from stone, hidden miles beneath the Earth's surface. The ceiling arches high above, supported by pillars of rock that have stood for millions of years. The walls curve in smooth, flowing lines shaped by countless years of heat and pressure. This is the magma chamber beneath Yellowstone. A cathedral of molten stone where Earth's deepest music plays. The magma that fills this vast space comes from far below. From depths where the rock is so hot that it cannot remain solid. It rises through narrow pathways like a slow elevator carrying heat from the Earth's deepest places. As it rises, it collects in the chamber like water pooling behind a dam. Year by year, century by century, the chamber fills with this patient, glowing liquid. This magma is not uniform like water in a bathtub. It contains different minerals, different gases, different temperatures all swirling together in slow, graceful currents. Imagine honey mixed with golden syrup, stirred gently with a wooden spoon. The patterns that form are complex and beautiful. They change so slowly that each swirl lasts longer than human civilizations. The hottest magma rises toward the top of the chamber like warm air rising in a room. The cooler, denser portions sink toward the bottom. This creates circulation patterns that are like the Earth's version of weather systems. Storm fronts of different temperatures and compositions move through the magma at a pace so slow it would make glaciers seem speedy. Crystals form and dissolve in this liquid rock like snowflakes made of fire. Some crystals grow over thousands of years, layer by layer, recording the changing conditions around them. Others melt back into the magma when temperatures shift. This constant process of crystallization and melting creates textures and patterns in the magma that are invisible from above but incredibly complex. Gases dissolved in the magma create their own subtle music. Carbon dioxide, water vapor, sulfur compounds, all of these are mixed into the molten rock under enormous pressure. They exist in a state between liquid and gas, neither fully one nor the other. As conditions change, these gases shift and move, creating pressure waves that travel through the magma like sound waves through air. The walls of the magma chamber are not solid barriers. They are more like the membrane of a living cell. Heat flows through them constantly. The surrounding rock warms and expands, then cools and contracts in cycles that last thousands of years. This breathing motion of the chamber walls adds another layer to the underground symphony. Sometimes small amounts of magma find pathways upward through cracks in the overlying rock. Like sap rising in a tree trunk in early spring. Most of this rising magma never reaches the surface. It cools and solidifies in the cracks, creating underground networks of hardened rock called dikes and sills. These form the plumbing system that connects the deep chamber to the thermal features above. The magma that does make it closer to the surface creates the heat that drives Yellowstone's geysers and hot springs. It warms the groundwater that seeps down from above. It creates the steam that erupts from Old Faithful. It provides the energy for all of the thermal wonders that visitors come to see. The visible features above are like the steam rising from a teacup, hinting at the warmth contained within. This vast underground system operates on timescales that dwarf human experience. The magma chamber has been filling and partially emptying for hundreds of thousands of years. The current chamber probably began forming after the last major caldera collapsed 640,000 years ago. Since then, it has been slowly accumulating magma, like a savings account that earns interest over geological time. Scientists study this hidden symphony using instruments that can detect the subtlest changes. Seismometers record tiny earthquakes caused by magma movement. GPS stations measure ground deformation that occurs when the chamber expands or contracts. Gas sensors analyze the chemistry of volcanic gases that escape through hot springs and fumaroles. These measurements reveal that the magma chamber is always in motion, always changing, always playing its slow music. Sometimes the chamber expands slightly as new magma arrives from below. Sometimes it contracts as magma cools and solidifies. Sometimes gases bubble up through the liquid rock, creating tiny tremors that instruments can detect but humans cannot feel. The temperature in the magma chamber ranges from about 1,400 to 1,800 degrees Fahrenheit. Hot enough to melt copper. Hot enough to turn limestone into marble. Yet this incredible heat exists in a state of perfect balance. The pressure from the overlying rock keeps the magma from boiling. The steady influx of new heat from below prevents it from cooling and solidifying. Different parts of the chamber have different compositions. Some areas are rich in silica, creating magma that is thick and sticky. Other areas contain more iron and magnesium, producing magma that flows more easily. These different compositions create layers and zones within the chamber, like different sections of an orchestra playing complementary parts. The magma also contains water, though not the kind you can drink. This water is dissolved into the molten rock at high pressure and temperature. It makes the magma less viscous, helping it flow more easily. When this water-rich magma eventually reaches lower pressure environments, the dissolved water becomes steam, providing the explosive energy that can drive volcanic eruptions. But most of the time, this water remains peacefully dissolved in the magma, contributing to the slow circulation patterns that mix and blend the molten rock. It acts like a lubricant, allowing different layers of magma to slide past each other smoothly, creating eddies and currents that flow like underwater rivers in a sea of liquid stone. As you rest tonight, this ancient symphony continues to play in the darkness below. Magma circulates through chambers vast enough to hold entire cities. Crystals grow and dissolve in patterns too slow for human eyes to follow. Gases rise and fall through liquid rock like bubbles in champagne that takes millennia to open. You are sleeping above one of Earth's most patient and persistent musical performances. A symphony that began before humans existed and will continue long after we are gone. And tomorrow, you will discover how this hidden music sometimes sends subtle signals to the surface, creating a language of tiny tremors and gentle movements that scientists have learned to read. Place your fingers gently on your wrist and feel your pulse. This steady rhythm tells the story of your heart's work. Each beat pushes blood through your body, carrying oxygen and nutrients to every cell. Your pulse quickens when you exercise. It slows when you rest. It changes with your emotions, your health, your state of mind. The Earth has a pulse too. But instead of heartbeats, it speaks in tiny movements and whispered vibrations. Instead of blood flowing through veins, it sends tremors through rock. And just like your pulse, these signals tell stories about what is happening deep inside. Scientists around Yellowstone have placed special instruments called seismographs in the ground. These sensitive devices are like mechanical doctors, constantly listening to the Earth's pulse. They can detect movements so small that they would be invisible to your eyes. Vibrations tinier than the width of a human hair. Shifts measured in fractions of inches. Imagine trying to hear a butterfly land on a pillow in the next room. That is how sensitive these instruments are. They record every tiny shake, every microscopic movement, every subtle change in the ground beneath your feet. They translate these movements into wavy lines on computer screens, creating a visual language that scientists have learned to read. Most of the time, these lines show gentle, rhythmic patterns, like watching the waves on a calm lake. Small earthquakes happen every day in the Yellowstone region. Most are so tiny that you would never feel them. They register as little blips on the seismograph recordings, brief moments when rocks deep underground adjust their position slightly. These tiny earthquakes are not signs of danger. They are signs of life. They show that the earth beneath you is active and healthy, like the small creaks and settles of an old house adjusting to changes in temperature. The rock is constantly responding to heat, pressure, and the slow movement of magma far below. Think of these micro-earthquakes as the Earth's way of stretching. When you wake up in the morning, you might stretch your arms and hear your joints pop gently. This releases small tensions that have built up while you slept. The Earth does something similar. As heat flows through rock and pressure changes deep below, tiny stresses build up. Small earthquakes release these stresses before they can become larger problems. Scientists have discovered that different types of earthquakes tell different stories. Sharp, quick tremors usually mean that rocks are breaking along fault lines. Deeper, more prolonged vibrations suggest that magma or hot fluids are moving underground. Each pattern has its own signature, its own meaning in the Earth's quiet language. Sometimes the instruments detect swarms of tiny earthquakes happening close together in time and space, like a cluster of small bubbles rising in a glass of carbonated water. These swarms often occur when underground fluids find new pathways through the rock. Hot water and steam, heated by the magma chamber below, create small fractures as they move toward the surface. The ground itself also moves in ways too slow for you to notice. Special GPS instruments placed around Yellowstone can measure changes in elevation that happen over months and years. They detect when the ground rises or falls by amount smaller than the thickness of a coin. These measurements show that the Earth's surface breathes like a sleeping person's chest. Over the past few decades, scientists have watched parts of the Yellowstone caldera rise and fall in gentle cycles. Sometimes an area will lift a few inches over several years, then slowly settle back down. This movement happens because the magma chamber below expands and contracts like a slowly beating heart. When new magma enters the chamber, the ground above rises slightly. When magma cools or moves elsewhere, the ground settles. These movements create maps of change that are invisible to casual observers but clear to scientific instruments. Colored computer maps show areas of uplift in warm colors like red and orange. Areas of subsidence appear in cool colors like blue and green. The maps look like weather patterns, showing the invisible storms of geological change happening beneath the surface. Temperature measurements add another layer to this story. Scientists place thermometers in the ground and in hot springs to monitor how heat flows from deep to shallow levels. These temperatures change slowly over time, reflecting shifts in the underground circulation of hot water and steam. Like taking the Earth's temperature to check its health. Gas emissions from hot springs and fumaroles provide chemical clues about conditions deep below. Scientists collect samples of these gases and analyze them in laboratories. The chemistry tells them about the temperature and pressure of the magma chamber. Changes in gas composition can indicate when new magma is arriving from deeper sources. All of these measurements together create a picture of a living, breathing system. The Earth beneath Yellowstone is not dormant or sleeping in the way you might imagine. It is active, dynamic, constantly adjusting and responding to forces operating on timescales much longer than human experience. What makes this monitoring so remarkable is how gentle and subtle these signals are. The Earth is not shouting or making dramatic announcements. Instead, it whispers. It speaks in a quiet voice that requires patient listening and careful attention to understand. The instruments are like translators, converting the Earth's whispered language into something humans can comprehend. Scientists who study these signals describe their work as listening to a conversation that has been going on for hundreds of thousands of years. Each measurement adds a new word to an ongoing story. Each day brings new data points in a narrative that spans geological time. They are reading a book written in earthquakes and ground movements, translated into the universal language of numbers and graphs. This continuous monitoring has taught scientists that volcanic systems like Yellowstone exist in a state of constant, subtle change. There is no such thing as complete stillness in the deep earth. Everything is always moving, always adjusting, always responding to forces both large and small. The art lies in learning which changes are part of normal, healthy activity and which might indicate something different happening. As you prepare for sleep tonight, you can rest knowing that this patient monitoring continues in the darkness. Sensitive instruments record every tiny movement, every subtle change, every whispered message from the depths below. Scientists work around the clock to listen to the Earth's quiet conversations, reading the signals that tell them about the gentle giant's dreams. And in this vast system of underground chambers and flowing heat, there is one place where these deep conversations become visible to the naked eye, where the Earth's patient whispers transform into the faithful, rhythmic voice that has been marking time in this landscape for generations. Imagine sitting quietly beside a pond at dawn, watching the surface break into perfect circles as a fish rises to feed. The ripples spread outward in gentle rings, marking time with natural precision. This is how Old Faithful speaks to the world. Not with words, but with rhythm. Not with noise, but with the patient language of water and steam. In a landscape filled with thousands of thermal features, Old Faithful stands apart like a master musician in an orchestra. While other geysers play their own melodies, some quick and playful, others deep and irregular, Old Faithful keeps steady time. Every hour to hour and a half, it sends a column of superheated water high into the sky. A living metronome in the Earth's grand symphony. You can set your watch by this ancient timekeeper, though it has been marking hours long before humans invented clocks. For thousands of years, Old Faithful has erupted with remarkable consistency. Native peoples knew its rhythm. Early explorers counted on its reliability. Today, millions of visitors gather around its crater, waiting for the next performance in this endless show. But Old Faithful is not alone in keeping time. Across Yellowstone's thermal basins, hundreds of geysers maintain their own schedules. Some erupt every few minutes with small bursts of steam and water. Others wait days, weeks, even months between eruptions. Each one operates like a unique instrument, tuned to its own underground plumbing system. The word geyser comes from the Icelandic word geyser, meaning to gush. But this simple definition barely captures the complex beauty of what actually happens. Each geyser is a delicate balance of heat, water, and underground architecture. Change any part of this system, and the entire rhythm shifts. Deep beneath each geyser lies a network of narrow tubes and chambers carved through rock by thousands of years of flowing water. Picture the inside of a flute, with its precise arrangement of holes and passages that create specific musical notes. Geyser plumbing works in a similar way. The size and shape of each underground chamber determines how the geyser will behave. Rainwater and snowmelt seep down through cracks in the rock, beginning a journey that can take decades or even centuries. This water travels deeper and deeper until it encounters the heat rising from the magma chamber below. Gradually, degree by degree, it warms from cool mountain runoff to superheated liquid approaching the boiling point. But this superheated water cannot boil immediately, even though it is far hotter than the boiling point at sea level. The weight of all the water and rock above creates enormous pressure. This pressure acts like a lid on a pressure cooker, forcing the water to stay liquid even at temperatures that would instantly turn it to steam at the surface. As more heated water rises from below, it begins to fill the underground chambers and passages. The system slowly builds pressure, like air being pumped into a balloon. The water column extends upward through narrow tubes toward the surface, carrying with it the accumulated heat of the deep earth. The magic happens when this column of superheated water finally reaches the point where pressure can no longer contain it. Usually, this occurs when water near the top of the column begins to cool slightly, creating just enough space for the first steam bubbles to form. These tiny bubbles trigger a chain reaction that moves downward through the entire system. As steam bubbles form and rise, they push water above them higher in the column. This reduces pressure throughout the system. Suddenly, water that was barely contained by pressure begins to flash into steam at multiple levels. What starts as a gentle bubbling becomes an explosive conversion of liquid to gas, sending water and steam shooting upward through the narrow tubes. The eruption that you see at the surface is the dramatic finale of this underground process. But the performance actually began hours earlier, with the slow accumulation of heat and pressure in chambers you cannot see. The visible eruption lasts only a few minutes. The preparation takes much longer. Old Faithful's consistency comes from the particular shape and size of its underground plumbing. The chambers and passages have been carved by water flow over thousands of years into a configuration that creates predictable behavior. Like a musical instrument that has been perfectly tuned, it produces the same note each time it is played. Other geysers have different underground architecture, which creates different rhythms. Castle Giza, with its tall cone of mineral deposits, erupts less frequently but for longer periods. Grand Giza, the tallest predictable geyser in the world, waits 8 to 12 hours between eruptions but shoots water over 200 feet high when it finally performs. The mineral deposits around each geyser tell the story of countless eruptions. Each time superheated water reaches the surface, it carries dissolved silica and other minerals from deep rock formations. When this mineral-rich water cools at the surface, it leaves behind tiny deposits. Layer by layer, eruption by eruption, these deposits build the colorful terraces and cones that surround each thermal feature. These mineral formations are like tree rings, recording the history of each geyser's activity. Scientists can read these deposits to understand how geysers have changed over time. Some formations show that certain geysers were more active in the past. Others reveal periods when underground plumbing shifted, changing eruption patterns. The thermal features of Yellowstone create a visible map of the underground heat distribution. Hot springs mark places where heated water reaches the surface gently, without the explosive pressure release of geysers. Fumaroles show locations where steam escapes directly, with little liquid water involved. Mud pots form where acidic water breaks down rock into clay, creating bubbling pools of heated earth. Each type of thermal feature represents a different way that the Earth's deep heat expresses itself at the surface. Together, they paint a landscape in steam and mineral colors, showing you exactly where the underground fire burns brightest. The entire Yellowstone thermal system is like a vast instrument panel, with each feature serving as a gauge that displays information about conditions far below. As you walk through these thermal areas, you are seeing the Earth's circulatory system made visible. You are witnessing the planet's way of releasing internal heat through thousands of carefully crafted vents and valves. You are observing a process that connects the deepest parts of our world to the atmosphere above. The rhythm of the geysers becomes part of your own rhythm as you spend time in this place. You begin to sense the patient timing of the Earth's breathing. You learn to anticipate the quiet rumbling that precedes an eruption. You start to feel connected to cycles that are much longer and deeper than your daily schedule. Tonight, as Old Faithful prepares for its next eruption in the darkness, and as countless other geysers maintain their patient schedules across the thermal basins, you can rest knowing that you have witnessed something remarkable. You have seen the Earth keeping time with the precision of a cosmic clock, marking the hours with displays of steam and water that connect the surface world to the dreaming fire below. And sometimes, when the Earth's patient rhythms shift slightly, these reliable timepieces might stutter or change their songs, reminding us that even the most faithful systems are part of a much larger, ever-changing dance. Have you ever watched someone sleep deeply and peacefully? Their breathing is slow and regular. Their body is still. But occasionally, they might shift position slightly. Roll from one side to the other. Stretch an arm or leg. These small movements don't mean they are waking up. They are simply adjusting to find a more comfortable position in their dreams. The sleeping giant beneath Yellowstone moves in much the same way. Most of the time, it rests quietly. The magma chamber breathes slowly with geological rhythm. Hot springs bubble gently. Geysers keep their faithful schedules. Everything continues in the peaceful pattern that has existed for thousands of years. But sometimes, like any deep sleeper, the giant shifts slightly in its rest. These movements are not signs of waking. They are natural adjustments that happen when any complex system maintains itself over long periods of time. Understanding these shifts helps us appreciate the difference between normal sleep movements and something more significant. Scientists have been watching the Yellowstone region carefully for decades, learning to read the subtle signs of the giants' movements. They have discovered that the ground rises and falls in gentle cycles, like the slow breathing of a sleeping person. Sometimes an area lifts a few inches over several years. Sometimes it settles back down. These movements happen so gradually that visitors never notice them. In the 1970s and 1980s, parts of the Yellowstone caldera rose by about 8 inches. This might sound alarming, but it happened over more than a decade. Spread across such a long time, the movement was gentler than the daily settling of a wooden house in changing weather. Scientists watched this gradual rise with interest, measuring and recording every tiny change. Then, in the mid-1980s, the rising stopped. The ground began to settle back down, returning most of the way to its original elevation by the end of the decade. This cycle of gentle rise and fall taught scientists important lessons about how the system beneath Yellowstone naturally adjusts and rebalances itself. These movements happen because the magma chamber far below expands and contracts like a very slow heartbeat. When new magma arrives from deeper in the earth, the chamber grows slightly larger. This pushes upward against the rock above, causing the ground surface to rise imperceptibly. When the magma cools or redistributes itself within the chamber, the pressure decreases and the ground settles back down. Imagine a balloon being slowly inflated and then allowed to deflate slightly. The rubber stretches and then relaxes. The rock above the magma chamber behaves in a similar way, though much more slowly and on a vastly larger scale. The balloon in this case is a chamber of molten rock larger than some entire cities. Small earthquake swarms sometimes accompany these ground movements. These are not the violent, destructive earthquakes that damage buildings and frighten people. Instead, they are tiny adjustments in the rock as it responds to changing pressure from below. Most are so small that only sensitive instruments can detect them. They register as little blips on seismograph records, like gentle sighs in the Earth's sleep. During the summer of 1985, a swarm of small earthquakes occurred in the northwestern part of Yellowstone Lake. Over several months, scientists recorded more than 3,000 tiny tremors in this area. The largest was barely strong enough to rattle dishes. Most were invisible to anyone not watching the instruments. This swarm was the giant's way of releasing small amounts of stress as the underground system adjusted itself. The pattern of these earthquake swarms helped scientists understand what is happening deep below. When earthquakes cluster in one area, it often means that underground fluids are moving through new pathways. Hot water and steam, heated by the magma chamber, create small fractures as they find routes toward the surface. The earthquakes mark the creation of these new underground highways. Sometimes the giant's movements affect the thermal features at the surface in subtle ways. Geysers might change their eruption intervals slightly. Hot springs might become a degree or two warmer or cooler. New thermal features occasionally appear while others fade away. These changes happen gradually, usually over months or years rather than days. Visitors often ask scientists whether these movements mean that Yellowstone is preparing to erupt. The answer is both simple and reassuring. These gentle adjustments are signs of a healthy, stable system. They show that the underground plumbing is working normally, releasing pressure gradually rather than allowing it to build to dangerous levels. Think of it like the safety valve on a pressure cooker. The valve releases small amounts of steam regularly to prevent too much pressure from building up inside. The earth beneath Yellowstone has thousands of natural safety valves, hot springs, geysers, and fumaroles that constantly release heat and pressure. The small movements and earthquake swarms are part of this natural pressure release system. Scientists have studied volcanic systems around the world and learned that the most dangerous volcanoes are often those that have been completely quiet for long periods. When a volcanic system has no way to release pressure gradually, that pressure can build up over time until something dramatic happens. Yellowstone's constant gentle activity is actually a sign that the system is healthy and stable. The monitoring instruments around Yellowstone continue to record these subtle movements 24 hours a day, 7 days a week. Scientists analyze the data carefully, looking for patterns that might indicate changes in the underground system. They have learned to distinguish between the normal sleep movements of the giant and anything that might be different or unusual. This continuous monitoring has revealed that Yellowstone exists in a state of dynamic equilibrium. It is always changing, always adjusting, always finding new ways to maintain balance. The ground rises and falls. Small earthquakes release tiny amounts of stress. Thermal features adjust their activity levels. All of these changes are part of the natural rhythm of a living geological system. As you rest tonight, you can take comfort in knowing that scientists are watching over this sleeping giant like caring nurses monitoring a patient's vital signs. They understand the difference between normal sleep movements and something that might require attention. They know how to read the Earth's quiet signals and interpret its gentle adjustments. The giant sleeps peacefully beneath the stars, occasionally shifting position, occasionally sighing, but always maintaining the deep, steady rhythm that has characterized this place for hundreds of thousands of years. And in its dreams, something even more remarkable unfolds, visions of ash dancing with sky, creating stories written in layers of stone that stretch across continents. On a quiet winter evening, stand at your window and watch snow falling. Each flake drifts down from the darkness above, catching streetlight as it spirals through the air. Some flakes are tiny and delicate. Others are large and fluffy. All of them began their journey high in the clouds, where water vapor transformed into ice crystals that learned to dance with gravity and wind. Volcanic ash falls in much the same way, though its journey begins not in clouds but in the Earth's deepest fires. What starts as molten rock in underground chambers eventually becomes tiny fragments of glass and stone that drift through the atmosphere like snow made from ancient dreams. These particles carry stories from the planet's interior, written in a language of minerals and time. When magma rises toward the surface during a volcanic eruption, it carries dissolved gases under tremendous pressure. Think of shaking a bottle of carbonated water and then opening the cap. The sudden release of pressure causes the dissolved gas to expand rapidly, creating bubbles that turn the liquid into foam. In magma, this same process happens with incredible violence and beauty. As the pressure drops, dissolved water vapor and other gases expand explosively within the rising magma. The molten rock shatters into billions of tiny fragments, each one a microscopic work of art. Some pieces are sharp and angular, like broken glass. Others are round and smooth, formed when liquid droplets cool rapidly in the air. Each particle tells the story of the moment it was born from fire. These fragments are so small that they weigh almost nothing. A handful of volcanic ash feels lighter than sand, lighter than soil, almost as light as flour. This weightlessness allows the particles to travel incredible distances on even the gentlest winds. What begins as solid rock deep in the earth becomes something that can float across continents like dust motes dancing in sunbeams. The largest volcanic eruption in Yellowstone's recent geological history happened 640,000 years ago. This eruption sent ash across most of what is now the western United States. Particles of Yellowstone rock fell like gray snow on landscapes that would one day become Kansas and Texas. Fish died in lakes thousands of miles away when ash settled into the water. Plants were buried under blankets of volcanic glass. But this ancient catastrophe also created something beautiful. The ash that fell across the continent became part of the soil that nourishes today's forests and grasslands. The minerals in volcanic ash are rich in nutrients that plants need to grow. Over hundreds of thousands of years, this ash weathered and mixed with organic matter to create some of the most fertile soils on Earth. You can still find layers of this ancient ash buried in rock formations across the western states. Geologists call these layers ash beds, and they serve as pages in Earth's history book. Each ash bed represents a moment in time when Yellowstone spoke to the sky, sending messages written in particles of glass and stone across vast distances. The ash from that ancient eruption was not uniform. Close to Yellowstone, the particles were large and heavy, pieces of rock and volcanic glass the size of pebbles. These fell quickly, creating thick deposits near the source. Farther away, only the finest particles reached the ground, dust so fine that it could stay suspended in the atmosphere for months, creating spectacular sunsets thousands of miles from the eruption. Scientists study these ash layers like archaeologists studying artifacts. Each particle of volcanic glass contains chemical fingerprints that tell them about the magma from which it came, the temperature at which it formed, the pressure conditions deep underground, the composition of gases that were dissolved in the molten rock. These tiny fragments are libraries of information about conditions that existed deep in the Earth hundreds of thousands of years ago. Modern instruments can analyze individual particles of volcanic glass smaller than the width of a human hair. Under powerful microscopes, these particles reveal intricate structures, hollow spheres where gas bubbles were trapped, twisted shapes where molten droplets spun through the air, sharp edges where solid rock shattered under unimaginable forces. Each particle is a frozen moment from one of Earth's most dramatic performances. The way ash travels through the atmosphere follows patterns that connect the solid Earth to the flowing sky. High-altitude winds carry the finest particles along predictable paths called jet streams. These rivers of fast-moving air circle the globe at altitudes where commercial airplanes fly. Volcanic ash can ride these invisible highways for thousands of miles, traveling farther and faster than any other natural Earth material. During its journey through the sky, volcanic ash interacts with sunlight in ways that create some of nature's most spectacular displays. The tiny glass particles scatter light differently than water droplets or ice crystals. They can turn sunsets deep red or purple, create halos around the sun, or make the moon appear blue or green. These optical effects can last for months after an eruption, as fine ash particles slowly settle out of the upper atmosphere. The ash also affects weather patterns in subtle ways. Dark particles absorb sunlight and warm the air around them. Light-colored particles reflect sunlight back to space, cooling the atmosphere below. Large volcanic eruptions can actually affect global climate for several years, as ash and gas in the upper atmosphere change how much sunlight reaches the Earth's surface. But most of the time, the dance between ash and sky happens on a smaller, gentler scale. Even during quiet periods, Yellowstone releases tiny amounts of volcanic particles through its thermal features. Hot springs sometimes bubble up microscopic fragments of rock from deep underground. Geysers occasionally carry traces of volcanic glass in their spray. These tiny contributions to the sky happen constantly, invisibly, as part of the ongoing conversation between Earth and atmosphere. Wildlife has learned to adapt to this ancient dance. Birds that live in volcanic regions often incorporate small amounts of volcanic ash in their diet, using the minerals to aid digestion. Plants that grow in volcanic soils develop root systems that can efficiently extract nutrients from ash-derived minerals. Entire ecosystems have evolved to thrive in landscapes shaped by the skybound journeys of volcanic particles. When you walk through Yellowstone today, you are walking on ground that contains ash from eruptions spanning hundreds of thousands of years. Each footstep lands on particles that once danced through ancient skies, carried by winds that no longer blow, deposited during seasons that happened long before humans existed. The soil beneath your feet is made partly from clouds that fell to Earth as gentle rain of stone. The trees around you grow in this ash-enriched earth, their roots extending down through layers of volcanic glass that mark different moments in geological time. Their leaves eventually fall and decompose, mixing with the ancient ash to create new soil for future forests. This cycle of growth and renewal connects the present moment to Yellowstone's volcanic past and future. As you prepare for sleep tonight, you can imagine the countless particles of volcanic glass that rest in the soil around the world, each one a messenger from Earth's deep interior that completed its journey from fire to sky to Earth. In their patient settling, they carry news of deep places and ancient times, finally coming to rest where new life can grow. And in the quiet spaces where ash has settled and time has worked its gentle magic, remarkable communities of life have learned not just to survive, but to flourish in the warm embrace of volcanic landscapes. Step carefully to the edge of a hot spring in Yellowstone and look down into the crystal-clear water. At first glance, the pool might seem empty of life, too hot, too acidic, too mineral-rich for anything to survive. But look more closely. Notice the rings of brilliant color that paint the edges of the water. Orange and yellow near the center, green and brown farther out. These are not mineral stains or chemical deposits. They are gardens. Living gardens made of some of Earth's most remarkable inhabitants. These colors come from tiny organisms called thermophiles, literally heat lovers. They are among the oldest forms of life on our planet, descendants of the very first living things that emerged billions of years ago when Earth was much hotter than it is today. While most life on Earth would perish in water hot enough to brew tea, these microscopic pioneers find such conditions perfect for their ancient way of living. Each hot spring is like a miniature world with its own climate zones. Near the center, where temperatures approach the boiling point, only the most heat-tolerant organisms can survive. These brave pioneers exist in water so hot it would scald your skin instantly. Yet they thrive there, growing and reproducing in conditions that would destroy almost every other form of life on Earth. As you move away from the hottest center toward the cooler edges, different communities take over. Each ring of color represents organisms adapted to specific temperatures. It is like walking from the equator toward the poles, but compressed into the space of a few feet. Each zone has its own residents, its own way of capturing energy, its own contribution to the hot spring's living rainbow. The bright orange and yellow organisms near the center are often bacteria that harvest energy directly from chemicals dissolved in the hot water. They do not need sunlight like plants do. Instead, they feast on sulfur compounds, iron, or other minerals that bubble up from the Earth's depths. They transform these simple chemicals into the energy they need to live, creating their own food in the eternal darkness of the deep thermal pools. These chemical-eating bacteria paint their surroundings with vibrant pigments that protect them from the intense heat and harsh chemistry of their environment. The colors are like tiny umbrellas, shielding delicate cellular machinery from conditions that would destroy ordinary cells. Each hue tells a story of survival in one of Earth's most extreme environments. Moving outward from the scalding center, you encounter cooler zones where other heat-loving organisms flourish. Here, temperatures that would still be uncomfortable for human skin feel mild and pleasant to bacteria adapted to thermal living. These organisms often form delicate mats and streamers that sway gently in the currents of heated water, like kelp forests in a warm, mineral-rich sea. Some of the most beautiful formations in these thermal gardens are created by cyanobacteria, ancient organisms that were among the first to learn how to capture energy from sunlight. These blue-green pioneers combine the old art of heat tolerance with the newer skill of photosynthesis. They create layered mats that look like living carpets, adding greens and blues to the hot spring's palette of colors. These thermal gardens are not just beautiful, they are laboratories where life experiments with survival in extreme conditions. The organisms living in Yellowstone's hot springs are helping scientists understand what life might look like on other planets. If simple organisms can thrive in the scalding, chemical-rich waters of Earth's thermal features, similar life might exist in the subsurface oceans of Jupiter's moons or in the warm springs that might flow on Mars. The hot springs also serve as nurseries for evolution. In the harsh conditions of thermal environments, genetic changes that might be harmful in ordinary circumstances can become advantages. Organisms evolve new ways to process chemicals, new methods of protection against heat, new strategies for capturing and storing energy. These innovations, tested in the crucible of extreme heat, sometimes prove useful in cooler environments as well. Even larger forms of life have learned to take advantage of thermal warmth. Yellowstone's hot springs and warm streams create refuges where plants and animals can survive harsh winters. While snow covers most of the landscape, green plants continue growing along the edges of thermal features. Insects that would normally die in freezing temperatures find warm havens near hot springs. Birds and mammals visit these areas to drink warm water and find ice-free zones during the coldest months. The thermal soils around hot springs are also special. Heated from below, they remain unfrozen even when air temperatures drop far below zero. This warmth allows root systems to stay active year-round, creating growing seasons that last much longer than anywhere else at Yellowstone's elevation. Some plants that grow near thermal features are found nowhere else in the region, evolved to take advantage of this underground heating system. Fish have discovered the benefits of thermal waters too. In Yellowstone's warm streams, certain species can remain active throughout winter while their relatives in colder waters become sluggish or dormant. These thermally adapted fish grow larger and live longer than those in ordinary streams, benefiting from the steady warmth and the rich communities of thermal organisms that serve as food. The interconnections between thermal life and the broader ecosystem create cascading benefits throughout Yellowstone. Nutrients from thermal organisms eventually flow into cooler streams and rivers, enriching distant habitats. Animals that feed near thermal features carry thermal-derived nutrients to other parts of the landscape when they travel and deposit waste. The warm refuges around hot springs serve as stepping stones for wildlife movement during harsh weather. Indigenous peoples who lived in the Yellowstone region for thousands of years understood these thermal oases as sacred places where life persisted even in the harshest seasons. They recognized hot springs as sources of both physical and spiritual warmth, places where the Earth's inner fire provided sanctuary for all living things. Their stories spoke of thermal areas as doorways between the world above and the powerful spirits below. Modern scientists continue to discover new forms of life in Yellowstone's thermal features. Each research expedition reveals previously unknown species of bacteria and other microorganisms. Some of these discoveries have led to important medical and industrial applications. Enzymes from heat-loving bacteria are now used in DNA research, manufacturing processes, and biotechnology applications around the world. The thermal gardens of Yellowstone remind us that life is far more creative and resilient than we often imagine. In places where early visitors saw only sterile, hostile landscapes, we now recognize some of Earth's most innovative biological communities. These gardens show us that what appears harsh or dangerous from our perspective might be paradise for organisms adapted to different conditions. As you drift toward sleep tonight, you can imagine the thermal gardens continuing their ancient work in the darkness. Microscopic gardeners tend their colorful communities in water heated by Earth's deepest fires. They paint living rainbows in conditions that stretch the very definition of what it means to be alive, teaching us that existence finds a way to flourish even in the most unexpected places. And in this remarkable ability of life to adapt and thrive in extreme conditions, we discover something profound about the patience and wisdom that governs all living systems across the vast stretches of geological time. Sit quietly for a moment and count your heartbeats. In just 1 minute, your heart beats about 70 times. In an hour, it beats over 4,000 times. In a single day, it completes more than 100,000 beats. This rhythm marks the time of your life, the tempo of your existence, the pace at which you experience the world around you. Now imagine a different kind of heartbeat. One so slow that a single pulse lasts 1,000 years. Where the pause between beats stretches across entire human civilizations. This is the rhythm of geological time, the patient tempo at which mountains grow and continents drift. It is a rhythm so deep and slow that it connects you to the very foundations of existence. The Yellowstone region teaches profound lessons about this kind of patience. The landscape you see today, with its lakes and valleys, its forests and meadows, its geysers and hot springs, represents just the latest sentence in a story that has been unfolding for millions of years. Every rock formation is a chapter. Every mineral deposit is a paragraph. Every thermal feature is a word in Earth's longest, slowest conversation with time. The mountains surrounding Yellowstone have watched this story unfold with the patience of stone. They have seen ice ages come and go like passing seasons. They have witnessed the birth and death of entire species. They have observed volcanic eruptions that reshaped the landscape in what, to them, were brief moments of excitement in otherwise peaceful millennia. These mountains teach you something remarkable about the nature of change. What seems permanent and unchanging in your daily life is actually in constant motion when viewed through geological eyes. The solid ground beneath your feet moves across the planet's surface at the speed your fingernails grow. The rocks that seem eternal are actually flowing like thick liquids on timescales you can barely imagine. This perspective transforms how you understand transformation itself. The changes that seem slow in human terms, the growth of forests, the carving of canyons, the wearing away of mountain peaks, are actually rapid movements in Earth's patient timeline. A forest that takes centuries to mature appears and disappears like grass growing in fast-forwarded film when viewed from the mountain's ancient perspective. The volcanic history of Yellowstone demonstrates this geological patience beautifully. The three massive eruptions that shaped the region happened 2.1 million, 1.3 million, and 640,000 years ago. From a human perspective, these events are impossibly ancient. But in geological terms, they are recent chapters in an ongoing story. The time between eruptions is like the pause between sentences in a very slow, very thoughtful conversation. Scientists who study these ancient eruptions learn patience from the rocks themselves. They spend years analyzing layers of ash and lava, reading the chemical signatures in crystals, measuring the age of minerals with instruments that can count individual atoms. Each measurement reveals another detail about events that happened long before human history began. This scientific patience mirrors the patience of the Earth itself. Just as mountains wait millennia between major changes, scientists wait years or decades for their research to reveal its secrets. They learn to think in timescales that stretch their imagination. They develop appreciation for processes so slow that entire careers can be spent studying single moments in geological time. The magma chamber beneath Yellowstone embodies this deep patience. For hundreds of thousands of years, it has been slowly accumulating molten rock from the depths below. The chamber fills like a rain barrel during a gentle, centuries-long shower. There is no hurry, no sense of urgency. The Earth knows that all things happen in their proper time. This underground patience creates the surface features you can observe today. The geysers that mark time with their regular eruptions are connected to heat sources that have been warming the same rocks for longer than humans have existed. The hot springs that bubble peacefully in their colorful pools draw their energy from fires that have been burning since before the first human footprints appeared on any continent. Even the wildlife in Yellowstone participates in this deep rhythm. The bison herds follow migration patterns that developed over thousands of years in response to seasonal changes and food availability. The wolves hunt in territories established through countless generations of trial and adaptation. The trees in the oldest forests have root systems that tap into soil chemistry altered by volcanic events from the distant past. Indigenous peoples who lived in this region for thousands of years understood these deeper rhythms intuitively. Their stories and traditions reflected awareness of time scales that extended far beyond individual lifetimes. They recognized that the land itself was a teacher, offering lessons about patience, persistence, and the proper relationship between human time and Earth time. Modern life often operates at a pace that can make geological patience seem foreign or irrelevant. We think in terms of minutes, days, seasons, years. We expect quick results, rapid changes, immediate responses. But the Yellowstone landscape invites you to experiment with a different kind of awareness, one that appreciates the beauty of processes that unfold slowly and steadily over unimaginable periods. This shift in time perspective can be deeply calming. When you recognize that the mountains around you have witnessed countless human dramas without losing their essential character, your own daily concerns take on a different quality. Problems that seem urgent and overwhelming become temporary weather patterns passing through the stable climate of geological time. The thermal features of Yellowstone offer perfect examples of this patient approach to existence. Old Faithful has been erupting on its reliable schedule for hundreds of years, possibly thousands. It maintains its rhythm not through hurry or anxiety, but through faithful adherence to the slow processes that govern its underground plumbing system. It teaches by example that consistency comes from patience, not from rushing. The hot springs paint their colorful edges through the accumulated work of countless small organisms over hundreds of years. Each ring of color represents generations of microscopic artists working steadily, adding tiny contributions to a masterpiece that improves with time. Their art teaches that the most beautiful creations often emerge from patient, persistent effort rather than dramatic gestures. Climate itself operates on these deeper timescales. The ice ages that carved Yellowstone's valleys and shaped its mountains moved at the pace of millimeters per year. Glacier advanced and retreated like slow-motion ocean tides, creating the landscape you see today through the gentle but persistent application of frozen water over tens of thousands of years. Learning to think in geological time does not mean abandoning human-scale concerns or responsibilities. Instead, it provides perspective that can inform daily choices with deeper wisdom. It suggests that the most important changes often happen gradually, through consistent small actions rather than dramatic gestures. It teaches that patience and persistence are among the most powerful forces in the universe. As you prepare for sleep tonight, you can rest in the knowledge that you are part of this vast, patient story. Your breath connects you to atmospheric cycles that have been operating for billions of years. Your heartbeat echoes rhythms that link you to all life that has ever existed. You are temporary, but you are also part of something permanent and ongoing. The mountains around you continue their slow meditation, holding space for all the quick dramas of shorter-lived beings while maintaining their deeper wisdom about the nature of time and change. And in their patient example, you might discover how the most profound transformations often happen quietly, in the gentle space between one moment and the next. As you settle into the quiet comfort of evening, the earth beneath you settles too. Your breathing slows and deepens, matching the ancient rhythm that has carried you through this gentle journey into the heart of sleeping giants. The day's thoughts begin to dissolve like morning mist, making space for the deeper currents of rest and renewal that flow through all living things. Tonight, while you sleep, the patient processes you have discovered will continue their timeless work. Deep beneath Yellowstone, magma will circulate through chambers vast as cathedral spaces, moving with the slow grace of honey through stone. Hot springs will bubble softly in the darkness, painting their edges with living colors that bloom unseen. Geysers will mark the hours with faithful eruptions, keeping time for sleeping forests and dreaming meadows. You have learned to see these powerful forces not as dangers to be feared, but as gentle expressions of Earth's ongoing creativity. The supervolcano that once seemed like a monster lurking beneath the landscape has revealed itself to be something much more beautiful, a sleeping giant whose dreams create the thermal wonders that make Yellowstone magical. Its enormous power operates with the patience of stone and the tenderness of a parent watching over sleeping children. This shift in understanding transforms not only how you see volcanic landscapes, but how you experience your own place in the natural world. You are not separate from these geological processes. You are part of them. The calcium in your bones came from ancient sea shells. The iron in your blood was forged in the hearts of dying stars. The water in your body once fell as rain on mountains that no longer exist. Every breath you take connects you to the atmosphere that blankets our planet, mixing gases released from hot springs with oxygen created by ancient forests. Every heartbeat pumps blood that carries minerals originally dissolved from volcanic rock. You are made of recycled earth, temporarily organized into the pattern you call yourself, eventually destined to rejoin the larger cycles of stone and water, air and fire. This perspective brings a deep peace that reaches beyond daily concerns. When you understand that you are part of Earth's ongoing story, your individual worries take their proper place within a much larger narrative. The challenges that seem overwhelming at human timescales become temporary weather patterns in the stable climate of geological time. What appears to be ending is actually transformation. What seems like destruction is often creation in disguise. The volcanic history of Yellowstone teaches this lesson beautifully. Each massive eruption that reshaped the landscape was followed by renewal. Where ancient calderas collapsed, new lakes formed. Where ash fell like gray snow, fertile soils eventually supported vast forests. Where lava flows sealed off river valleys, new thermal features emerged to heal the landscape with warm springs and gentle steam. This cycle of destruction and creation, ending and beginning, continues at every scale throughout the natural world. Your own body replaces its cells continuously, rebuilding itself completely every 7 years while maintaining the pattern you recognize as yourself. Trees shed their leaves each autumn only to grow new ones each spring. Rivers carve new channels while filling old ones with sediment. Everything flows, everything changes, everything begins again. The thermal features that dot Yellowstone's landscape demonstrate this principle of continuous renewal. Each eruption of Old Faithful is both an ending and a beginning. The water that shoots skyward falls back to Earth, eventually seeping down through rock to begin its journey toward the next eruption. The cycle completes itself endlessly, each repetition both familiar and unique. Scientists who study volcanic systems have learned to appreciate this perspective of constant change within apparent stability. They know that the absence of major eruptions does not mean the system is dormant. Instead, it means the system is healthy, releasing pressure gradually through thousands of small vents rather than building toward dramatic events. The most stable volcanic systems are often the most active at small scales. This teaches a profound lesson about how to live with power and energy. The most sustainable way to work with intense forces, whether geological or personal, is not to suppress them or fear them, but to find gentle ways to express them regularly. Like thermal vents releasing pressure gradually, we thrive when we find healthy outlets for our own inner fires. As you prepare for sleep, you can rest knowing that you are participating in one of Earth's most ancient and essential activities. Sleep is the original renewable energy system, the way consciousness restores itself for another day of experiencing the world. While you rest, your body repairs tissues, consolidates memories, and prepares for tomorrow's adventures. Your dreams may carry you to places you have never seen, or help you understand experiences from the day in new ways. The Earth dreams too, in its own geological way. The slow circulation of magma through underground chambers might be the planet's version of dreaming, moving materials and heat in patterns that create new possibilities. The patient accumulation of pressure and its gentle release through surface features might be Earth's way of processing the intense energies generated in its deep interior. Tomorrow, when you wake refreshed from your rest, the geological processes you have learned about will continue their patient work. New water will seep down through rock toward the heat below. New magma will rise from deeper sources to replenish underground chambers. New thermal features might form while others fade away. The endless conversation between heat and stone, pressure and release, will write new chapters in Earth's longest story. You will wake to a world that is both exactly the same and completely different from the one you left behind in sleep. The mountains will occupy the same positions, but microscopic amounts of new rock will have formed in their depths. The geysers will continue their familiar schedules, but each eruption will be unique in its own subtle way. The hot springs will display their living colors, but the communities of heat-loving organisms will have grown and changed in ways too small for casual observation. This is the gentle miracle of existence, everything constantly changing while maintaining the patterns that allow for continuity. And in this endless dance between change and stability, between sleeping and waking, between endings and beginnings, you find your place as both observer and participant in the most beautiful story ever told. In your dreams tonight, you might return to the places you have visited on this journey, seeing them now with eyes that recognize the patient fire that burns beneath all peaceful surfaces.